In this video, I want to review adding and subtracting fractions. Now, adding and subtractions, the big thing you have to remember is that you do need common denominators, which means that the denominators have to be the same. Now, what happens here if they are the same, I should probably make this a capital D, right? Then they're very quick and easy. So for instance, if I have something like what is 4/7 plus 1/7. So there I have common denominators already. I can just add. So it's very, very quick. This would be 4 plus 1. On the top, I would keep my denominator, and I would have 5/7. Now, if I could simplify that, I would still want to do that at the end. And it's the same thing for subtracting. So let's say I had something like maybe 7/10 minus 3/10. Our denominators are the same. There's really not much to do there. You're going to just follow the directions. In the numerator, I will do 7 minus 3. I will get 4, and I will keep that denominator. Then at the very end, you do want to check if you can simplify that, you would. And my final answer here would be 2/5. So when they're already the same, they're going to be very quick and simple. The problem is what to do when they're not the same. And you're going to have to find a common denominator. So let's look at an example. So something like maybe 1/3 plus 4. Now it's 2/7. So here these denominators are definitely different, right? And there's different ways that you can think about finding that common denominator. But basically what you need to do is you need to find what we call there are different ways to find the least common denominator. We often abbreviate that LCD, by the way. Least just means the smallest. So actually any denominator that's the same is totally fine. But if you can find the smallest one, it just keeps the numbers smaller and makes your life easier. Now, there's different ways to do it. A very basic way, if you're having trouble starting out, is to think about your multiples. So you can use a multiples list. So I could start with the number 3 and then the number 7, and I'm going to list the multiples. That is times 1, times 2, times 3, and so on. So for instance, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times, let's see, 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24, 3 times 9 is 27, and I'll stop at 3 times 10 is 30. And then you do the same thing for 7. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28. And what you're going to do is you're going to stop when you see one in common. So that's really all you're doing here. And as you get more comfortable, you can sort of just do this in your head and think about, well, if I think about my multiples, what would they have in common there? Another way to think of it is you could say to yourself, well, what number would these both go into, right? Like 3 times what and 7 times what would give me the same number. So when you're looking for a common denominator, the answer is usually bigger, not smaller, which is a common mistake. So I'm going to use 21 here. And what I'm going to do is I'm going to take that 1/3. I'm going to change it to 21. I'm going to take that 4/7 and I'm also going to change it to 21. So you would think, well, how do I get from 3 to 21? I would multiply that by 7, and you make the same exact change on top. 7 times 1 is 7. How do I get from 7 to 21? I multiply that by 3. And 4 times 3 is going to be 12. So the problem ends up becoming, instead of 1/3 plus 4/7, we'll write it as 7/21 plus 12/21. And then now you have a problem that you can work with. 7 plus 12 is going to be 19. 21 stays. So remember, you're doing all that work to get to that denominator, so it's going to stay as 21. If you could simplify at the end, you would. Let's do another one. All right, so 1/2 plus 2/3. So again, we're trying to get to something, right, where they're both the same denominator. Right now, they're different. So you can either think in your head, okay, well, what could I use? What multiple would work? Or again, if you're having trouble, you're going to write it out. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, etc. And you're going to do the threes. 3 times 1 is 3, 3 times 2 is 6, and then you're going to notice, hey, they both work with 6. So you're asking yourself, what is a number that both of these are factors of? What is a number that they both divide into? And in this case, 6 is going to work. And then you're going to change each of these over individually. So how do we get from 2 to 6? That would be multiplication by 3. We do the same change on top. 1 times 3 is 3. And then here, how do we get to 3 to 6? Move this up a little bit. That is times 2, and 2 times 2 is 4. So my problem becomes a 3 plus 4 is 7/6, or if you want as a mixed number, 1 and 1/6 would be correct here. So we have to figure out what number could be in common between the two, and use that. Now, another shortcut that I know some students have learned is that they'll just multiply the denominators together. That does work too. It may not always be the smallest one though. So let me just do one more. How about we do a subtraction one? So let me do 17/20 minus 1/5. So now again, I like to think about my multiples. What number did these both work with? Well, if I think about 20, 20 times 1 is 20, 20 times 2 is 40, 20 times 3 is 60. If I think about 5, 5 times 1 is 5, times 2 is 10, times 3 is 15, times 4 is 20. And I can see that that value of 20 occurs in both. So again, I'm looking for a number that both of these will divide into or are factors of. So I'm going to use 20 here. Now, if you're using the multiplying technique, 20 times 5 will give you an answer that works, but it's 100. So your numbers are getting a lot bigger. So we typically like to do the smallest number or the first one that we can find. Now, 17/20, I don't have to change. It already has the 20. So I just have to change the 1/5. And what's happening here is I would multiply that by 4. And then I can subtract 17 minus 4 is 13, again, all over 20 here, which happens to be simplified. So that would be the final result. Now, again, there's lots of ways that you can find a common denominator. This is my favorite strategy because I think it's pretty quick. If your numbers get really large, though, or you're getting stuck or this is taking too long, you can always multiply the denominators together. That will give you a viable common denominator. It's just that your numbers will get quite large. And then don't forget to, you still have to change each fraction over individually. So make sure you don't forget that step. Now, the other thing I'd like to talk to you guys about are mixed numbers. And there are 2 different ways that you can do mixed numbers. So I'm just going to show you like a couple of little examples here. Excuse me. All right, so let's do this one. 7 4/5 plus 2 3/5. Let's do an easy one first that already has common denominators. So this one already has common denominators, which is nice. I don't have to worry about it here. So let me show you the 2 strategies you can do. So the first one is that the same thing that we were doing for multiplication and division, and we were using improper fractions. So that technique still works for adding and subtracting. It works for all four of them. So I would get 5 times 7 is 35. Let's see, plus 4 would be 39 over 5. Here I'd have 10 plus 3 is 13. I'd add my numerator together here. I get 52 over 5. And then I can change this back over. And when I go ahead and do that, I do get, let's see, 5 goes into 52 10 times with a remainder of 2. So 10 and 2/5. And that still works. Now, the other strategy, though, is you actually can leave them as mixed numbers. Again, this only works for adding and subtracting. It does not work for multiplying and dividing. I don't really have an easy shortcut there. So what you could do is you would write it like this: 7 and 4/5 plus 2 and 3/5. And you would add the individual parts together. So that actually does work here. 4 and 3 is 7, so you get 7/5. And then 7 and 2 is 9. Now, the only problem with adding is that you may end up with an improper fraction, which you'll have to fix. So 7 over 5 is the same thing as 1 and 2/5. So then what you do is you fix your answer. I put the 9 and the 1 together, which is where I get the 10, and then it just stays as 2/5. So you can do both. Either way is good. Now, if you don't have common denominators, you still have to get that first. So let me do one example where we do not have common denominators. So let's do, how about 2 and 1/3 plus 4 and let's do 5/6. So the first strategy is going to be to change everything to improper fractions. So I would do 3 times 2 is 6 plus 1 is 7. So I'm going to do 7/3. And then 6 times 4 is 24. And then let's see, plus 5 is 29. So 29 over 6. And then you're still going to have to go through your process for getting common denominators. This is a great time if you want to pause the video and actually try this on your own. Think about what the common denominator would be here. It would be 6. So if you think about your multiples, 6 actually works in both of them. And what happens for the first one to get from 3 to 6, you would multiply that by 2. So this is going to become 14 over 6, and the 29 over 6 is going to stay. And then now we're going to go ahead and we're going to add. So I'd have 29 and 14. That's going to be 43 over 6. Let's see, 6 goes into 43 7 times, which is 42, and I have a remainder of 1. So I have 7 and 1/6. And of course, if you could simplify your fractions, you would still do that here. The second way to do it is a little bit different. It allows you to leave it as a mixed number. But you still need to have common denominators. So what's going to happen is you would want to rewrite these with your common denominator. We already saw it is going to be 6. So the 5/6 is fine. But to get from 3 to 6, you would multiply that by 2. So you would have to change this to 2 and 2/6 at the start of the problem. So you're finding those common denominators right away. And then you can add. So I have 2 and 2/6 plus 4 and 5/6. 2 and 5 is 7, so I have 7/6. Here I have 6. And again, it doesn't always happen, but sometimes you do get those improper fractions. So you'll have to fix that. That's the same thing as 1 and 1/6. And if I put my two whole numbers together now, there's that 7 and 1/6. So it's completely your choice with how you want to deal with mixed numbers. If you're struggling with this idea of trying to carry, this is how we carry with fractions, the improper method always works. You don't have to learn anything new. The only downside is that your numbers do get pretty large quite fast. So if that bothers you, then you may want to try to learn a new strategy. But otherwise, they do both work. Let me show you a little bit what happens with subtraction. So how do we subtract when we have fractions and mixed numbers in particular? All right, so we can do the same thing here. I'll show you two strategies. So one is to change everything to improper, nothing new to learn. So here I have, let's see, 35 plus 1, so 36 fifths. Let's see, 15 plus 2 is 17, so 17 thirds. You do still need common denominators. So if you need to, you can make out your multiples list here. The first number that works for both is 15, right? Because 5 times 3 is 15 and 3 times 5 is 15. So I can change these both over to 15. Now, if you want to write it out off to the side, you can. If you're feeling pretty comfortable at this point, I will usually still write it out, but do my work more on the problem. So to get to 15, I'd have to do 5 times 3. And then let's see, I'd have to change over 36 times 3. So let's see, that's 18, so 108. And then here, 3 times 5 would give me 15. So I need to do 17 times 5. So you can see with the impropers, it's not bad, but the numbers do get large fast. So either be careful with your calculator, or if you're doing things by hand, again, you just want to be really careful because those numbers can get big quickly. And then we're going to go ahead and subtract those, and we should get 23 over 15. That goes in one time. Let's see, with a remainder of 8, it looks like. So 8 over 15. So nothing new. Again, the downside is the numbers get big quickly because we have to change to common denominators. But otherwise, again, there's really nothing new that you have to learn here. The second strategy is to leave it as a mixed number. Oops, mixed number. So you still do need to have your common denominators. So what you'll have to do is change to common denominators right away. So we're going to make this over 15 and this over 15. So as we said, 5 times 3 is 15. So that gives you a 3 here. And 3 times 5 is 15, which gives you a 10. And we're going to set this up vertically. Excuse me. All right. Now, what you may be saying to yourself is, I have to subtract these, but I can't do 3 minus 10, right? Think about your regular numbers. You have to borrow. 3, I can't do 3 take away 10. I don't have enough stuff. So I need to borrow. So you're going to borrow 1 from the 7 and make it 6. But here's where it gets weird. This is not going to be a 13. In fractions, things are not necessarily broken up into groups of 10s. They're broken up by the denominator. So whenever you borrow, you're actually going to not just put a 1 in front and make it a group of 10. You're going to add whatever the denominator is. So that this now becomes 18 over 15 as your top fraction. And that is the tricky part. So with fractions, that denominator tells you how many pieces you have, right? Like if I had a pizza and I was cutting it into 8 pieces, I would need 8 slices for a whole. So that's what we're doing here. If I'm borrowing a whole, well, it's like, well, how many slices do I have in that whole? In this case, I have 15. So that's what has to get added into the numerator here when we borrow. Now we can do 18 minus 10 is 8. 15 stays, and 6 minus 5 is 1. And you can see there's the same answer we had up above. But borrowing with fractions is a little bit trickier. We're not just adding a 1 in front. It depends on the denominator. So whatever your denominator is, that's how much you're adding in those cases. So again, just a little bit different to think about here. Let me do one more example. I'll do one that already has common denominators just so you can see it. So let's say I had something like 10 and, I don't know, 4/13 minus 8 and 7/13. All right, so again, I'm going to do it the second strategy. I want to subtract here. I don't want to convert over, but I can't do 4 minus 7. I'm going to borrow from the 10 and make that a 9. But instead, I'm going to add in whatever the denominator is. So 4 plus 13 is going to be 17. So my top fraction is actually 17 over 13. Now 17 minus 7 is 10. And 9 minus 8 is 1. So it can be really quick to borrow with fractions if you don't forget about that change when we're bringing it over. It's not always a factor of 10 like we're used to. It depends on the denominator here. So that's how you can borrow with mixed numbers.